Okay, welcome to 8.1, integration by parts. So we're going to kind of set this up by looking at some of your differentiation rules from Calc 1. If you remember the power functions, if you take the derivative of x to the n, the power comes out to the front of the x variable and you reduce the power by 1, and this of course doesn't work when your exponent is 0. And then integrating by the power rule, you add 1 to the power and you divide by that new power into your x term. And we can't use that if x is equal, or excuse me, if n is equal to -1, because then we're looking at our natural log integration. All right, some other ones we've looked at: the chain rule. To do the chain rule, we've done a couple of these. That's the substitution method of integration. And next, the one that we're going to look at is the product rule. When you take the derivative, that's going to be called integration by parts. So if we look at the derivative rule, whoops, a little quick there. If we look at our product rule, you multiply two functions and you are taking the derivative. You take the derivative of the first function times the original second function plus the original f function times the derivative of your second g function. So what I'm going to do is I'm going to integrate both sides of this. So if I integrate the derivative, I will get the integral of this first product plus I'll integrate the second product. Then what we do is we go ahead and we cancel these two right here. It gives us f of x times g of x. And then what I'm going to do is I'm going to subtract over this first integral over to the left. And then we isolate the f of x times g prime of x dx. If we do that, we get our integration by parts rule. So simplifying to get the integration by parts, we shorten all this notation. So we're going to let u be just f of x, du will be dx, dv, that's going to be the derivative of the g function dx, and v would be g of x. I guess I got my clicks out of order here, but that's okay. So we'll label everything up here. So here's my u dv. So this is what we're going to see as our integration. We're trying to integrate u dv. Then we're going to write that as uv minus the integral of v du. And there's our du. So we're just using variables here to shorten all that notation, if you will, just doing the product rule to set up the integration. Now, a very useful acronym for choosing your u is as follow, L-I-A-T-E. So first, the L stands for logarithms. I stands for inverse trig functions. A stands for algebra, T stands for trig functions, and E stands for exponentials. So in this order, if you see your function u dv and you see a log, you want to call that u, and whatever else you have left over, that's going to be your dv. Oops, I guess I lost my exponentials. All right, so reminders. Choose u whose du is simple. All right, we want to keep du very simple. dv, where your integral is easy to find. dv always includes dx from the original integral. All right, so let's apply these rules in some examples here. So let's say we're trying to integrate f of x times cosine x dx. So you can see we have a product of two functions, hence the product rule. All right. So if we go through our list. Do we have any log functions? No. Do I have any inverse trig functions? No. Do I have any algebra functions? Yes. My x is my algebra function. So u is going to be my x. My dv is going to be my cosine x dx. And one thing that I would ask you to do is keep writing this for every single problem, because the more you write out the formula, the faster you're going to commit it to memory. And again, it's also on that integration sheet that I asked you to print out. All right, so with x being my u, take the derivative of x, that's dx. Cosine x dx is my dv. What we want to do is we want to integrate it. So if, again, you check your list, if you integrate cosine of x, that's sine of x. So what we're going to do is we're going to come over here, and now we're going to rewrite this part right here. My u, that's the x. My v, that's the sine of x. Minus the integral of v, sine of x. And then my du, which is just the dx. And from here, I can integrate sine of x. Sine of x is negative cosine x. Don't forget your plus c, because we have no bounds. Then the minus the negative will change that to a plus, and you are done. So it's like we just did the integral of the product rule, but we call it integration by parts. Okay, second example. Again, get your u, dv, du, dv, or v box ready. Get your LIATE ready to go. Look at your integral, and let's clean this up. We don't need the scalar factor of 3, so let's factor it to the front. And so now analyze what we have here. I don't see a log function. I see no inverse. I see a for algebra. That's my x. E to the 2x, that's exponential. That's at the bottom of the list. So again, we're going to let x be our u. So again, write down your integration by parts formula. Integrating u dv is going to be uv minus the integral of v du. This is what we want. dv, that's going to be e to the 2x dx. And now taking the derivative of x, just like above, that will be dx. And the nice thing here, integrating e to the 2x dx, because it's base e, you know you're going to get the same thing, except for one slight issue, that 2x, all right, that's your chain rule, if you will. We're going to have to do a u sub. So think about 2x being u, not this over here, but isolating that out. Then you have the derivative of 2x is 2, and you have to divide over the 2 to the dx. So that will be 1/2 e to the 2x as your integral. So what I kind of like to remember seeing this is, remember with your derivative rule for the chain rule, you took the derivative of the outside, then you multiplied it by the derivative of the inside. You took the derivative of the outside function, then you multiply it by the derivative of the inside function. So when you integrate the outer function, and then you divide by the derivative of the inside function. So that's that 1/2 right here, dividing by the 2. All right, so we substitute everything in. My u is going to be my x times my v, which is 1/2 e to the 2x, minus the integral of 1/2 e to the 2x dx. And all of that, remember, still bring down your 3 out in front. So again, the nice thing again here, when you have these exponential functions, you've already integrated it right here. So if you want to think about this, you're going to have 1/2 times 1/2 e to the 2x right there. Don't forget to put in your plus c, and then we'll multiply everything out. So 3 distributed in, that will give us 3x over 2 e to the 2x minus 3 over 4 or 3e to the 2x over 4, or 3/4 with your plus c. Whoops. All right. Example 3. All right, here we have, again, 3x times the natural log of x dx. Let's set this up. I see a natural log, a logarithm right here. So that's going to be my u. Again, 3 you could factor out to the front, or I chose this time to leave it in there just so you can see it doesn't matter whether you factor out or not, you would still get the same answer. That's my dv. So now take the derivative of the natural log of x, that will be 1 over x dx. And then if we integrate 3x, that will be 3x squared divided by 2, or 3/2 x squared. So now we can substitute everything in. We'll get our u will be the natural log of x times v, 3/2 x squared, minus the integral 3/2 x squared times 1 over x dx. So this time our du happened to have a little bit extra with it besides the dx. So what we're going to do here is we're going to simplify this multiplication. This x can cancel out one of the x's in the x squared. And now I factored out the 3/2. And we'll integrate x to be x squared over 2 plus c. Multiply the 1 over 2 with the 3/2 to get a minus 3/4. And there's our final answer. Example 4, we want to integrate the natural log of x dx. Well, L is going to be the natural log, that's my u, and just dx will be my dv. Du, take the derivative of that, that will be 1 over x dx. Integrate dx, that will be just x. So plug everything in, we'll get natural log of x times x minus the integral of x times 1 over x dx. We cancel out the x's, which means we just integrate dx, which is like saying there's a 1 there, so that's just going to be a minus x plus c. And there is examples of integration by parts.